Hello everyone, welcome to the electrical circuit simulation series. In this session we will study the use of OPAMP as a differentiator. So it will differentiate the input. There is a derivative of the input. So this is the required circuit diagram. Okay, we use a OPAMP, capacitor, resistor. Let us see the components. So the first component is the OPAMP itself. Okay. Then we have the input wave generator. So we'll be using a triangular wave as the input. We'll see how we set it. Then we have a resistor of 10 kilo ohms, and we have a capacitor of 10 microfarad, and then we have the ground which is connected to the non-inverting. So here we can see the input is connected to the inverting end through the resistor and through the capacitor, and the resistor is used as the feedback. Now we also need an oscilloscope. Oscilloscope will be used to see the waveform. So here there are 4 channels. We only use the 2 channels because there are 2 waves. One is the input, other is the output. So the yellow, as you can see, the yellow channel, the channel 1 is connected to the input, and the purple one, light purple, is connected to the output. So we are using 2 channels. Now we have to do one setting for the power supply for the input. So we need to have input as the triangular wave. So why are we using a triangular wave? Because we want to see the functioning of the OPAMP as a differentiator. So it will differentiate the input. So output is the differential of the input. So if the input is triangle, then output will of course be a square wave. So if we know the basics of derivatives, so if the input is a triangle, then of course output will be a square wave. Okay? So this is the triangle wave we will be using. We need to set this. By default it is sine wave. We need to set it as a triangle wave. Now this is the input and the output waveform which will be seen on the oscilloscope. I'll show this on the simulation. So as we can see, the upper wave, the yellow one, is the input, the triangular wave, and the output, as we can see, it is a square wave. So it is the differentiate. If we differentiate the input, which is a triangular wave, we get output as a square wave. So this is the input wave, okay, and this is the output wave. Now this is the output calculation. So the theory says that the output is minus RC times derivative of the input dVi upon dt. So whatever input we are giving, we get the output as the differential of it, and also the RC multiplied with the RC. So this is how it works. So when the input is going towards the high end, okay, so from 0 to high, slope wise, we get, this is the yellow, the red line is the slope of this particular wave. Okay, it is not 0, it is starting from some voltage. Then when it is going towards the negative end, we get the positive. Now why it is going the negative? Because as we can see, V0 is minus RC. So when the input is going towards the slope, the slope is going towards the positive end from 0 to high, okay, from low value to high value, we get the output in the low state, and when it is going from high to low, we get the high state. So this, because this is a negative sign, okay, so input is connected to the negative end. So that's all for this this explanation. Now let us go to SimulIDE to perform this practical. So now we are into the SimulIDE software. Let us design the circuit. So for that purpose we need, first of all, we start with an OPAMP. So we select the OPAMP. So this is the OPAMP. Now by default this OPAMP will be such that the inverting would be down and non-inverting up. So let us flip this. It will work anyway, but generally we give the feedback, the negative feedback. So we are keeping this negative and up. Then we need a capacitor. So here is the capacitor. So capacitor is at the input terminal, inverting terminal. Then we need a resistor. So we keep a resistor here. We'll change the value afterwards. Then we need a ground. So this is the ground. We keep it here. Then we need an input. For input we use the wave generator. This is the wave generator. Okay. Then for checking the output we require oscilloscope. This is the oscilloscope. We keep it here. Now we do the connections, then we do the settings. So this is the input, then this input to capacitor the output of capacitor is given to this non-inverting end. Then we are keeping this particular resistor in the feedback path. So this completes. Then finally the non-inverting terminal is connected to ground. This is the ground connection. And then we have the output. So for getting the output, what we do is we use two terminals. This one terminal, the yellow one, we use for getting the input, checking the input. This is the input. And for output we use this another terminal. So this is the output terminal. This is the output. It will give us the output. Now next, before turning it on, we need to do some settings for the OPAMP. So I just right click in the properties. If we go for the supply, you can see plus volt is 5. So let us make it 10. Okay. And minus is 0. So these are the saturation voltages. So let us give the saturation, keep it is minus 10 volt. We are getting minus 10 volt. Okay, it's the power supply we are connecting, the dual power supply. So if we don't do this, we won't get the negative part of the output. So we do this, and then the value of this resistor, it is 100 ohms. We'll make this as 10 kilo ohms. So this 10, and here this is kilo ohms. Okay. And then the input part, the last setting. So we go into the properties. So as in the main, we can see the wave type. It can be sine, sawtooth, triangle, square, random. So it gives out these different types of waveforms. So let us select the triangular wave. Okay. So why are we doing this? Because this circuit is working as a differentiator. So when the input to a differentiator is a triangular wave, output is a square wave. So when the input is triangle, output is a square. That I've already explained in the slides. Okay, so this is the input. We don't change any input voltage now. So let us start the simulation. So now let us start the power supply. So here we are getting the output. So I'll just expand this. Okay, so this waveform of the output is going out of range. So I'll just click on channel 2 and increase this voltage level so that we get within the range. Okay, so I keep it as a 5 volt per division. Let us take it 5 volt per division. Okay, so this is the, as you can see, the two waveforms we can see. This, the yellow is the input. Okay, and we can, if you want, we can actually put it up. So we can change this position, time positions, voltage position. We can change it up. So let us take it up. So I am changing taking the input up and come to channel 2 and bring this down. Okay, so this is properly visible now. Let us change the time settings so that we get more proper visuals. Okay, so this is the input is a triangle and output is a square. So this is how the differentiator works. Why it is called as differentiator is natural that output is the differential of the input. So whatever input we are giving, it differentiates and gives as the output. Same way we have the integrator, which we'll see in the next video. So that's all for this particular session. Thanks for watching.